Okay, so I'm Dave. You might remember me from such things as yesterday and the day before. And as with those, I want to, again, thank all of the CHAC Masters folks that were involved for the support, and in particular, the review, the tutorial review that was done by Anne Farley, Michael Mosqueda, and Dia Nguyen. So thank you very much. I appreciate your efforts, and it really helps make these notebooks more usable. All right, so if you recall yesterday, we talked about some advanced, well, more advanced data structures than the basic data types, which you can think of as integers, floating points, and string numbers, or sorry, strings, floating point numbers and strings. And yesterday we talked about lists and dictionaries. And when I'm declaring a list, I see there's a hand raised. Before I get into that, was there a hand raised or no? Okay. If you remember, when you're declaring a list, or you see a list printed out, what about a list lets you know that it's a list? Anybody remember? Has a certain kind of bracket. It was the square brackets, right? And so when we see lists, like the ones we saw yesterday, you'll see a list of things, comma separated set of values that include the brackets around them. If you remember that lists are ordered, meaning the order that objects are put into a list is preserved throughout the lifetime of that list, unless you change the order through operations. And some of the neat things that you can do with lists is you can slice them, like we see right here. Oops, like we see right here. And what this does, if you remember, is this will return a slice of that list, meaning a subset of that list that includes the elements with indexes 0, 1, and 2. And so remember, we start counting at 0. And the upper bound on a slice, meaning the 3 here, is exclusive. We do not include that. So we count from 0, 1, 2, and then stop because we don't count 3. Let's see. We also talked about dictionaries. And if you recall, the thing that differentiates a dictionary versus an other collection is the curly braces that you see around dictionaries. And also this key value pairing inside of a list of elements in the dictionary. And so we call these keys and these values. And so in this little simple dictionary here, we have 2 keys, cake and toenails, which have the values tasty and gross respectively. And so this is the basis of sort of named access versus index or numerical access like a list does. And so if we wanted to pull out the definition for the word cake, for example, or pull out the value for the key cake, we can reference that in a dictionary using this. And sometimes this can be confusing because here you see the square brace, the square bracket, I mean, instead of the curly brace. The addressing is the same, but the difference really appears when they're being initialized. And also another thing, if you recall, we did initialize empty lists and empty dictionaries. And the way to do that is to, let me scroll down, is to create an empty list like this, and then an empty dictionary like this. Now, granted, you don't know what I'm using A and B for in this instance, but what's the consensus? Are A and B good variable names ever? Probably not. There may be a small number of cases, but generally speaking, when you're using a variable, you want to come up with a name that's a little bit more human readable and interpretable than A and B. Okay, so that was our review of some of those data structures from yesterday. And if you recall, those data structures gave us the, that's what I wanted to do. The data structures gave us a way to use things like loops. And actually, in the if statement, we were looking for our first if statement, if you recall, was looking for a particular value inside of a list. And then when we moved to loops, we looped over elements in a list. And so there's in Python, and perhaps more so than in other programming languages, there's a really tight coupling between some data structures and some parts of flow control. And so this idea of having a branch where we do a particular, we execute a particular set of statements or a block of code in when a condition is true or when a condition is false. So those are our if statements. And so they're typically written like, if a statement is true, we would go down this branch, and then else, if a statement is false, we would go down another branch. And so if statements are one of the core pieces of flow control, which is the idea of controlling the flow of execution in our code. And then loops being another critical piece, where if we haven't reached the end of our list, keep operating on, keep running statements on a particular set of values and run them over and over again until we've reached our termination condition, which very often is the end of a list. And then we exit out of that loop. So today we're going to get into this sort of other component here, this idea of sort of sequential blocks of code. And these rectangular blocks here are meant to sort of be the conceptual blocks of code, right? The things that you indent, because remember in Python, indentation is important to grouping statements together in what's called a block of statements. And if the word statement is opaque or overly jargonesque, we're really talking about lines of code. So now we're going to move on to this idea of a function. And you may have actually had this already happen to you, probably not so far in the CHAC, but if you've written code before, you may have had a situation where you have a little bit of code that does something like maybe it calculates an average, right? And then you want to calculate a number of different averages. And so what you do is you copy that code and then you paste it somewhere else and you change something like which variable it's computing the average over. And then, oh, you want to take the average of another set of numbers. And so you copy that code again. And what you end up with eventually is a lot of duplicate code where the only thing that's really different is, say, in that example of calculating a mean or an average of a set of numbers, is which numbers you're calculating the mean or average of, right? So there's some variable component, but the core sort of set of statements of the activity of the calculation are the same. And that's really the domain of functions. And you can imagine that case that I just described, where in your code, you calculate averages of a couple different sets of numbers. And so you started out with writing it once, and then you copy and pasted it, and then you've got it in 8 different places. And let's say you realize along the way that there was a way to make it faster, or that alongside of computing the mean, you could compute the standard deviation. And now you've got 8 places in your code where you've got pretty much identical lines with maybe one variable named different somewhere, and you have to go edit them all. And so that kind of leads to an unsustainability of your code. And also it leads to a lot of redundancy of the code. So using the copying and pasting bits of code over and over and over again can actually lead to a sort of a bloated base of code that can be difficult to maintain. And if you ever find a bug in one of those pieces of code that you copied over and over and over again, you now have to fix it in 8 places. And it can be hard to remember where all those whatever 8 places were. So the idea behind a function is that you can take something like computing the mean or standard deviation, which is a relatively rote and straightforward calculation, and encapsulate it into a set of statements that are sort of self-consistent and coherent, where only one or a small number of components, like variables in that calculation, change. And that's, again, the fundamental idea of a function. And so in that, again, that case that I just gave you where you've got 8 copies of this code to calculate the mean and standard deviation, you could have written that once as a function and then called it in 8 different places. And if there was an issue with the code, like there was a bug or you wanted to implement computing standard deviation at the same time, then it's trivial. You fix it in one place and you have that feature or that bug fix all over your code, every place you call that function. And let's talk about some examples of functions. When we were talking about lists, we had the append function, right, that appended an element to the end of a list. There's one function that we've been using over and over and over again, which is the print function, right? Is that you give it a variable or a value and it prints it out. And so that's probably the function that we've had the most experience with. But you can define your own functions, and that's super cool, and that's what we're going to talk about right now. So the general sort of form, excuse me, the general form for defining a function looks like this, where we have the reserved word or keyword def, excuse me, followed by your name of the function. And we talked a little bit about programming style yesterday, but generally the way that you write function names is that they are lowercase. And if you want a space, like you have a concept like mean and standard deviation as your function name, you could do all lowercase mean underscore and underscore standard dev or something like that. And that's really, it's really intuitive to a reader of that code who sees that function. Oh, I get what this function is doing. So function naming is important. And then we see there's a place here where we can provide some parameters. And this is like when you copied that code all over and you were just changing which list of numbers you wanted to compute the average of. This is sort of the variable part of the code each time you call that function. And so again, think of the print statement. The inside of the print function works the same way every time, but it varies depending on what you pass it as the parameter or the argument. Those are sometimes used interchangeably. I use them interchangeably. So that's what the parameters are, and we'll talk more about those in a little bit. Another important thing that's pretty easy to neglect at the beginning is this doc string. And Jesse talked about this on day one. And we talked about hashtags, using hashtags as comments. And that's a great thing to do. In Python, there is this concept of a doc string, and it's a multi-line comment, essentially, that's set off by 3 triple double quotes. So triple because there's 3 and they're double quotes. This is one of the few places in Python where it matters whether you choose single or double quotes. And it matters mostly from a style perspective in that everybody in the world uses triple doubles for this. The other thing I want to point out here is that once we see the double dots here and we enter into the function itself, you see the indent, right? And this is the same as the indent for the if and the for, in that we're setting off a set of statements that appear here and saying, hey, these belong to this function that I'm defining, okay? So the indent is very important. It defines what the code block is associated with this function definition. So there's our optional doc string there. And like I said, it's easy early on not to write these. I encourage you to get in the practice of writing them because even if they're relatively thin, it builds a habit, which is a good habit to have. And you could write hundreds of thousands of lines of code using many functions and never write doc strings. And what happens is you incur what's called a technical debt, meaning you haven't really done the documentation for your code. And you've got a lot of code suddenly, and now you have a huge workload to do to go back and to write all that documentation. So I encourage you, even if your doc strings are relatively thin, just to get in the habit of writing doc strings that look like this. The functions will work totally fine without them, but avoid the technical debt if you can, and do that work up front. The next thing that we would see here is a bunch of statements or expressions. This can be any number of lines long. Again, it's important that they're indented, but this is really the work of the function. So in the case of computing, say, the mean, this would be the statements that compute the mean from, say, a list of integers or floating point numbers. And then optionally, you can have a return statement. And this really signifies the end of a function, although, yeah, let's just leave it at that. And sometimes you actually want to return a value. And so in the case of computing a mean, right, we could go in here and calculate the value of the mean, but we need to somehow get that back to the function that called it. And that's where this return statement really shines, is the ability to return some value back to the code that called the function that you defined. And with any luck, we'll have time to get through some examples of that today. All right. So let's start with a really simple example. This is a function, a contrived function that I made called print string. And I define it here. And there we have our name of this function called print string. And it takes one parameter called stir. And in this case, you can think of that as the value that will change every time I run this function, print string. So every time I run this function, there could be anything in there, and I'm going to use that anything and do something with it. So whatever I pass in my calling thing gets substituted in for this value of string. And then down here, we actually call the real Python print function. And then we return, meaning this is the end of the function. We'll move on. So this is an incredibly simple function. It's redundant with the print function. And so, it doesn't serve a particular purpose other than for us to have some fun and play with it. I think one thing that I want to point out is I probably should not have used a parameter called str. Because there is a function in Python called str, which is used for casting things to strings. And so I regret that choice. And I wish I'd thought of that before now. But let this be a do as I say, not as I do example. And so this will work totally fine, but it's not good form for me to be trying to use a variable name that conflicts with a core Python component. So, really what I should do is write something like string, and then over here, write string. And that way I've differentiated my function parameter and variable from the built-in function in Python str. So this will work just fine by changing that to a string. And I encourage you to do that in your notebook, but don't worry if you don't feel like doing it. All right. Now to use our function, we use it like we've been using functions before, right? And the way you know something is a function call, meaning we're calling a function, is we have the name of the function and then the parentheses, and then a list of parameters inside the function. And so when this gets called here, when the print string function gets called, what Python does is it comes here and it collects up the things in between the parentheses, and those become the parameters. And then they get substituted in for the variables here. So when this function starts running with this input, the value of string is equal to Dave is awesome, right? Okay, so let's actually call this function and see what happens. So here we have print string, and we've got the string Dave is okay as our parameter. And that gets substituted in for string, and then this gets ignored, the triple double gets ignored because effectively it's a comment, right? And then we get to the actual meat of our function call, which is really to use the print function itself to print out the contents of our string. And that's where we see this from. And then the return statement gets hit, and the execution goes back to where the function was called from. And we can make that a little bit more explicit by saying something like, the function has ended, right? And so my point in showing you this is when the print string function runs, the return statement is found, and the thread of execution, the thread of our flow control, returns back to this statement in our cell, and then we see that output, right? So this is that concept of flow control up here where we see the sequence diagram, where this box here is a function, right? And so the thread of execution comes in and executes the statements in that function, and then it leaves and it picks up back into the main body of code. It finds another function, it enters into it, it leaves, it comes back into the main body of code, and so on and so forth. And so these three components are ultimately really the core of flow control in most programming languages out there. Okay, so this is our print string function that, sorry, this is our print string function that we've defined. And so far, we've always called it with a parameter or with an argument, and in a string in this case. What happens if we call it without an argument? Well, we get an error. And that's Python telling us that the print string function has one required argument that's missing. And this string here is telling us, this actually refers back up here to the name of the parameter that's missing in the function definition. So that's where this string is coming from. And you don't have to follow along with this, but I can just make that a little bit more clear by calling this A, B, C, D, E and executing that cell. And when I come over here, you can see it's telling me this parameter in my function definition up here was not supplied by the caller. That's what it's telling me, missing one required parameter, A, B, C, D, E. And so again, I don't think that A, B, C, D, E is a very good variable name. I think string for this is a much better variable name. And so I'm going to put that back to string. OK. And again, if I run this again, I'll see that that gets swapped out for this. OK. So that's the basics of a function and how functions are defined. Any questions on this before I get into more about function parameters?
Can you pass a function as a parameter to a function?
You absolutely can. I love these meta things. So you can pass anything you want as a function parameter. Except for like a reserved word or something like that, right? So any valid variable or data object can be a recursion. It's recursion, but it's actually even cooler than that. But anyway, the point is that you can pass anything you want to a function, whether or not it can be coerced into a data type that's usable by that function is a totally different story, right? And so let's see, if we pass in 4, it's smart enough to say, OK, here's an integer that I passed in, not a string, but an integer. But up here in this statement, the print function itself is smart enough to say, oh, well, somebody passed in a number, but I know how to convert numbers to strings, so I'm going to coerce it or typecast it, was the language I think I used yesterday, into a string, and therefore we can print it out. And so this works fine. Floating point numbers will also work fine. And functions, it's surprisingly enough, will work fine. And that's because the print statement or the print function as defined in Python is really smart. And when you pass it an entity that happens to be a function, it actually knows how to coerce or cast that entity into a string. And so this is the string that gets printed by print string. So that's a great question. And it gets to, again, sort of it's pretty meta, the things that you can do when you can pass around things like this. So yeah, great question. And any other questions?
Yeah, I have a question.
Yeah, go.
Yeah, so with functions, if a function outputs like a list, and you want to at the same time give a function parameters and call its like one of the elements of this list that it outputs, how would you do that? So, do you know what I mean?
Let me see if I can. Let's see. So you have a function that takes a list, right?
Mm-hmm.
And then it returns another list, something like this.
It doesn't have to take a list.
Okay.
It could take just one or two, maybe variables, and then it would return like a list, or it could be a list of numbers or whatever. And then you simultaneously want to call the function and its output, if that makes sense. So you'll say like my function of this variable and this variable, and I want to say you would use square brackets and call the element of what it returns.
Yeah, let me. Oops.
Sorry if that's really specific.
Nope. This is great. Again, this is a fun one to kind of wrap our heads around. So let's just execute this. So here's our function. It takes two. Oh wow, that's neat. That highlighting. Do y'all see that highlighting? Oh, that's kind of cool.
Mm-hmm.
So this is a function that takes two inputs, and we're trying to give the user a hint that we want them to be numbers. So it takes two inputs, a number and b number, and then it returns a list. And you know it's a list by the way it is. It returns a list that has three elements in it: the a number, the b number, and then a number times the b number, right? And so that gives us this list out. And then I think what you're asking me is, can I do that?
Right, yeah.
Yep, so you absolutely can. So what's going on here, let's just unpack this for a second, is that this function is executing. And when it's done executing, in your head, you can kind of swap this bit out here for what is effectively the return of this, right? So imagine that this now, that piece in your code got replaced by this, and then you're asking it you're indexing into that list that got returned. This is a totally valid way to use a function. So yeah, you can absolutely do this kind of thing. And thank you for the question, because I like it, because it gives me an opportunity to point out that functions can return anything that they want. So here we're returning a list. Can I do this? I don't know if yeah, that's pretty crazy. Let's see if that'll work. All right. Don't try this at home, folks. Yeah, wow, that's pretty insane. That's uber meta. Okay, but I think my point here was that thanks for pointing that out, because that allows us, that we can return pretty much anything we want from a return statement, including a list, and then you can immediately access that return result. And in this instance, you know what's interesting about this is that this result here wasn't ever put into a variable. It was sort of an anonymous thing, right? And we accessed the element we want, and then it evaporated and is gone. So that's a great question. I want to make sure I answered exactly what you wanted to know.
Oh, I think you did. Yeah. Okay. Just want to know if that was kind of the way of writing that out, or if there was a way to do that without, defining a variable first.
Yeah. So this is totally acceptable, and you will probably see it in a lot of places. I mentioned yesterday that I am a stylista when it comes to code, and so while this is totally valid, I think that it may be easier for for most folks, what did I say, two, right? To process mentally some code that looks like this. And while I said that this result before, when I didn't instantiate into a variable, is anonymous, that's true. But the sort of the memory and garbage collection systems of these make these almost equivalent. And so this arguably is more clear to a reader, and there's no functional difference to the computer. And so I might argue that the clarity of this overweighs sort of the compactness and cuteness of doing it in another way. Any other questions about this? These are great questions. I love them, by the way. All right. Cool. Let's move on to function parameters. All right. So this is kind of a fun concept to wrap our minds around. But in Python, our parameters or arguments are what's called pass by reference, meaning that if you pass in something like a list, like we see here as our parameter or argument, we're not copying it before we pass it in. We're not making a copy of the original list and putting it in the variable mylist. We're actually taking the original list, bringing it into the function, and so therefore modifications that are made will persist outside of that function. And so if we look at this code here, change list, it takes one argument, a list, and appends to that list the string 4, and then prints out that list, and then returns. So if we look down here where we create a list of 3 elements, 1, 2, 3, and then we print out that list before we call the function, I think we would recognize that this is going to print out in brackets 1, 2, 3, and then change list will run. The list 1, 2, 3 gets passed in, and now this will get appended. Sorry, this will append the string 4 to this list and print out inside of our function the number 1, the number 2, the number 3, and then the string 4. And then when we leave the list and we run it again, or sorry, when we print this statement again, you'll see that the list remains modified. And so this is the concept of pass by reference. And maybe to make this more clear, I will, instead of calling this my list, which could be confusing, I will call it a list. A list, as in all the celebrities that come to my birthday parties. Okay. All right. And I just want to emphasize that this variable name here is not connected in any way to this variable name, but the contents of this are placed into this variable. And again, it's called by reference. And so it's a reference to the original value, not to a copy, to the original. And so when this runs here, we append it to the list. And then Python hits the return statement and comes back here and prints it again. And you can see the original list was modified. So this might not seem like a big deal, but it actually kind of is a big deal, because you may kind of in your head assume that copies are being made when in fact they're not. And then your function does something with a list and the original function is modified, destroyed, changed, or otherwise altered in a way that you didn't expect. So generally speaking, you want to think of things like lists as pass by reference. Let me create another little example here. Let's see, return. And then we'll call this mynum equals 42, which is, of course, the best number. Okay, and let's, okay, so here we go. We have my num that I set to 42, right? And so this is an integer. And it gets put into our function here as 42. And then that variable gets reset to 4. And that's printed out as 4 right here. And then the function returns, and you see 42 again. So there's the returned, and then you see 42 again. And you might think to yourself, well, Dave, you just said that these things are passed by reference. And so why isn't the original value of my num being 4? Like, wouldn't you expect it at this point to be 4? Well, the pass by reference really applies to things beyond the simple data types. So beyond the strings, the integers, and floating point numbers. And so again, if you're just passing in simple data types, then effectively you can imagine that things won't be changed inside the function. But as soon as you start passing in more complex data structures and operations and things like that, that's when things start to get passed by reference. So this is actually a kind of a challenging topic, and something that I think can create some bugs and issues. And so I want to take a moment just to make sure that this is clear, what's going on and how this can impact your use of variables inside of functions and outside of functions. Okay. Never feel shy about slowing me down or stopping me. I'm always willing to go back to if something suddenly didn't make sense before. Please don't hesitate to raise your hand and draw my attention to it. I am going to skip over this section about global and local variables. It's actually an important topic, but it's something that we can probably wait on. And if I have enough extra time in today's tutorial, I will come back to this. But if you're interested after today's tutorial, I do suggest that most folks come through and look through this if we don't have time to go over it, because it's actually a pretty important pretty important idea. And like by reference, it's something that will save you a lot of headaches in your life. All right, let's talk about parameter types. So if you remember up here, let's see, where was it? When I called my function without an argument, let's see, I can make it happen again. So it was print string. Oh my, I should just use tab completion, right? When I called print string without an argument, it said that my function is missing one required positional argument, string. And let's come down here to where we talk about, there we go, argument or parameter types. And there's this idea of a required argument or parameter, meaning it has to be present or you'll generate an error. And that's what we just saw. And it's positional in the sense that if you have a function like this one here that will print out a name given a first and a last, actually this is not a great example. Let's use the example up here. If you have a function that has two parameters, first name and last name, the order that they appear is important. So if I put the last name in the first spot, if I do something like my func and then put in my last name and then my first name, if this was going to print out the things and it expected the value of my first name to be in the first argument and the value of my last name to be in the second argument, then the output would be wrong, right? It would print my last name and my first name. So that's the concept of a required positional argument, meaning it has to be there or the function call will generate an error. And positional, meaning the order that they appear is important. Another kind of variable is a keyword, parameter or argument is a keyword parameter or argument. So in this one, in this example where there's a definition, they're positional and important. In this example here, because they are named and there is a value provided here, they can be, the order can be changed, right? And so this is what's, oh, whoops, just move my screen around. This is what's called a keyword argument, and therefore they behave position independent. So if we look at this example here, we have a required argument, which is first, and then a position or a keyword, a named argument that is position independent. Although since there's only so many places that can go, it ends up at the end. And then many of these keyword arguments end up having default values, which is how this works here, where we have a default value for the argument. And so if I called this function without any parameter in the, if I just gave it the first parameter, my first name, and didn't give it any more arguments, what it would do is substitute in this value as the default value for the last name. So let's play with this a little bit. So there we go. And if I, again, just to make this concrete, if I did print name and my own name, what happened is the thread of execution came in here and substituted the string Dave for the value of the parameter first. And then it didn't see anything beyond that. So there were no named or keyword arguments beyond that. And so it defaulted to the default value that was defined when the function was defined or declared. And then again, I didn't spend a lot of time talking about this yesterday, but quickly, when you have the F preceding a string and then in curly braces, a variable name, that's what gets substituted in here. So that's how this formatting here ends up with my first value here and then last value here. There was a great link in yesterday's tutorial about how F strings work, and I'll refer you back to that. But you can probably play with them and figure it out pretty quickly. So there we go. Print name Dave works, but I can also supply a value for the last name, in which case it'll override the default that was provided here and then appear in the output that we see. So let's just play with one other quick example here, which is to say, if I did something like that, what you can see is I supplied a named variable, right? I supplied a keyword named variable last, but I broke up the positional order, right? I supplied it before all the positional order, positional parameters or arguments were supplied. And therefore that created an error, a runtime error a syntax error in Python that said that, hey, you put a keyword or positional argument before you put your required, you put the positional or required argument after you put the keyword argument. So the order of things matters. When you can create functions that can supply defaults, that's always great. One thing I would recommend is if you're going to do that, which is great, I should have had a doc string in here saying the last name default is a fun joke, right? So I probably should have put a doc string in there to define why I chose that default last name. All right. Yeah, I guess let's spend a little bit more time on string formatting. I forgot that I had put this in here. This is a great time to talk about string formatting. Because you will very quickly come to the point where you want to print out things other than just having it be the last value that appears in a cell. Sorry, that should have been a 3. Right? That's not really gonna that doesn't really work for printing things out. That you generally want to start to do string substitutions. And so there is this thing in newer versions of Python. I know it's Python 3.6 and beyond. There's this concept of a thing called an F string. And they're called an F string here because they're for formatting strings, but also because they begin the string. So there's the string constant between 2 quotes. And there's an F that sets off the string. And what it says to Python, hey, look, this is a fancy F string. Let's go and substitute some values into this string. And so what Python will do is it'll take my favorite number, substitute and set that value to 42. And then when this runs, Python sees the F in front of the string constant and says, oh, this means something I should probably try to format. And then it looks in here for any curly braces and it finds a curly brace grouping. And then it says, what's inside of that curly brace is going to be a variable name. And so it substitutes the current value for that variable into that part of the string without the curly braces. And so if we were to run this, this is supposed to be a code cell. Let's see. Nope, that's definitely not what I wanted to do. But I'll do it this way. And so what you can see here is we have my favorite number equals 42, and then this runs, and so the value for 42 gets piped in or placed into this. What's really cool is within the strings, this is why I think they're the bee's knees, is within the strings, you can perform operations. So I took my favorite number 42 and multiplied it by 2, and you can see in the output that comes out as 84. And it doesn't just work for numbers, like I showed you here. Here's a place where we've got a, oh, that's going to drive me nuts. Where we've got a string, and the string is liger, and you might ask what a liger is, and it's my favorite animal. And so that gets substituted into here in this string, and then we can do this over and over and over again. And so that's a quote from Napoleon Dynamite, I think, for anybody who's really interested. All right. So that's a brief detour into F strings. They're your best friends, some of your best friends, and they definitely are the bee's knees. Okay, a question came up that I want to answer, which is what if you added a second keyword argument such as middle? Could you pass middle after last? So that's a great question. So let's come up here and let's call this middle equals, and you said a keyword argument. So let's put something in here like, well, let's leave it blank because, you know, not everybody has a middle name. And then in our F string, we'll put our middle here. And so if we sort of, if we guess what this is going to do in this case, right, if this is our function definition, and let me run that, and then we call it with print name Dave, it should print out your name is Dave, and then nothing, because this is an empty string, right? So the empty string gets substituted in here, and then the C hacker, right? So let's just do that, demonstrate that. And you can notice here that we see two spaces, and there are clever things that we could do to fix that, but we're not going to go over that. But that's this space here, and then this space here. So that's why there's two spaces in there. But the question really was, can I do last equals Beck, and then middle equals danger? And absolutely. So once the keywords, once you relieve the positional arguments, you are free to supply the keyword arguments in any order you want. And that's kind of the beauty of keyword arguments. And if they have defaults, you don't have to supply them at all, right? So again, if I ran this one again, it's just going to have the double spaces in there. So thank you. That's a great question. If you remember up here, I said that all the sort of awesomeness of programming comes from flow control, right? And yesterday we talked about taking if statements and putting them inside for loops. And then we put for loops and kind of for loops. And then like, yeah, things got crazy and fun. And the same is true with functions. Where am I? Okay. The same is true with functions. And so anything that we can put at any point inside of Python, anything that we put in Python statements, we can put inside of a function. And so that includes things like if statements and for loops. And so here's an example where we have a function where you give it, these are required positional arguments, the first name, last name, and age. And then we'll print it out and then print out the age. This is another way of doing formatting. Let me really quickly convert this to the kind that we've been talking about so that it's a bit more consistent. There we go. So that's using an F string. And then we have an if statement here that looks at the age. And if it's above the age that my kids think is really old, then it prints out is really old. So let's see this example here. Okay. Wait, oh, I didn't actually. In case you didn't catch what happened there is I never ran this cell. And so it was telling me there is no function print name age. So let me run this cell to define the function. And now we have our function defined, and I can call it again. And because I used the parameter names here, I can actually put them in order that I want. But if I tried to remove these keywords here, right, it's going to try, well, let's just run it. But what it tried to do is it tried to use 46 as first and Beck as last, which isn't that wrong. And then it tried to use Dave as my age. And so this didn't print out right. You can see that your age is Dave, didn't print out right. And then when it tried to do the math here, you can't do an integer comparison between you know, a number and a string. And in fact, that's what it's telling me. So I can't do a greater than comparison between an instance of a string and an integer. Okay, so that's why having those, when you name the variables like that, you can put them in different orders. Again, as a style thing, if I'm using the named way of supplying parameters or arguments to a function, I generally try to get them to match the order that they appear in the function definition. And that's just a, you know, it's a simplicity and readability thing. Let's see, there is a way, if I hover over it, I know in straight Jupyter, I can actually put my cursor inside of here and bring up the function definition. How do I do that in Colab? Does anybody remember? I'm looking at you, Wes.
You have to be typing in it. So you do print name age, open parenthesis. You have to get rid of everything after it, I think, for it to get juiced. There you go.
Thank you. I appreciate that juice there, Wes.
Yeah.
And so one of the things I just want to point out is that once you define your functions, if you don't remember the order that they appear in, both Jupyter Notebook and Colab will do this thing where we'll try to show you the function definition. And in fact, if I think this will work in Colab. And then execute that so the function is defined. And then if I come in here, yeah. So this is another reason to put docstrings in, people. If you weren't motivated by the fact of the thinking of technical debt, this is a cool thing that Colab and Jupyter Notebooks do, is that in addition to being able to show you the calling synopsis, that's what we're seeing here is called the synopsis, it will also show you what's in the docstring. This is a great reason to put those docstrings in and look like a professional. All right. Okay. All right. That's a good point. Thank you, Wes. It may not work for you by default, was what Wes let us know. All right. So that's functions. I want to start moving on to some of the other parts of the scientific Python toolkit. But any last questions on functions before we roll forward? All right. Cool. So there's this thing that's often called the Python Scientific Toolkit, or Scientific Python Toolkit, or Python Scientific Stack, or ecosystem, or whatever. And it's rich and complex, but it generally has 4 core components to it. And that is Numpy, which is a library that has a whole bunch of numerical Python stuff in it. In particular, it's for very efficient manipulation of arrays of data. So if you remember yesterday, we were talking about making lists of lists to encode a matrix. You can do that, but it won't perform anywhere near as quickly as Numpy will. So Numpy has a lot of tools for working on arrays and vectors and doing array and vector operations. And so nobody here is an astronomer, so you probably don't know what IDL is, but if you've used MATLAB, Numpy should feel relatively familiar. The other one is Scipy. And Scipy is a little bit more of a catch-all. So Scipy includes things like optimization of numerical optimization of functions, numerical integration, interpolation and spline fitting are all in there. There's a ton of awesome stuff in Scipy. And if you're thinking, wow, I'd really like to try using this numerical method X, before you go implement it yourself, look in Scipy, because there's a good chance that it's already there, like for numerical differentiation or something like that. Pandas is really where I want to focus today, because this is kind of the bread and butter of data management, two-dimensional data management in Python. And what I mean by two-dimensional data management is it looks like a spreadsheet. It looks like an Excel spreadsheet, right? Where you have columns, and that first row is a header row where you're naming all the columns. And then in the rows, you've got data that correspond to those columns, right? So it's two-dimensional and that you have rows and columns. And you can imagine that this idea of a panel of data, or a two-dimensional panel of data, is really useful, right? Anytime you want to load in data that you would normally think of in a spreadsheet is a great time to think about using Pandas. And in fact, Pandas can load Excel spreadsheets directly without a lot of work. So Pandas is super cool. And this idea of a two-dimensional piece of data is called a data frame. And that's borrowed from the statistical programming language R, which at some point I would love to talk to you about in another setting. Okay, then Matplotlib is kind of the basis of visualization. It's the most accessible and ubiquitous visualization tool in Python. I would not say it's the best, but it's a great place to get started. So these 4 things generally comprise this scientific ecosystem in Python. And today we're really going to get into pandas because that's where all the good stuff happens. And under the hood, actually, what you might not know is that under the hood, pandas is using things like Scipy and Numpy. And that's why it can perform so fast. All right, but before we can use pandas, we have to import. Now, Jesse and I have already hinted at the idea of import, but the idea behind import is that, look, somebody else has already done a whole bunch of heavy lifting, writing some great code to do something, and rather than you inventing the wheel, you want to import all that goodness into your own code and use it. And so here's a really basic example where we could import the pandas library, and then we would have access to all the stuff inside the pandas library. And if we come up here and oops, and I do open link in new tab, you can go find the pandas documentation here. And so all of the stuff that we can get through pandas, we can get by importing it. So that's what a typical import statement looks like. Sometimes you want to use pieces of a library, but not all the rest of the library. And so there's this idea of from a library, import just one or two things. And that's what we're doing here is in the scikit-learn, which is a great starting point for machine learning in Python. In scikit-learn, there are a bunch of demo data sets. And what we want to do is reach into that scikit-learn package. And then inside of scikit-learn, there's another module called datasets. And then inside of that, we want to find the function load Boston and import that back into our notebook or into our Python interpreter. And just really quickly, there's a word that you should know of, and that's called a namespace. And what we're doing here is we're importing pandas into our global namespace. And here, what we're doing is we're importing load Boston into our global namespace. And namespaces are important, and I know you all memorized the Zen of Python yesterday. And one of those lines, one of the lines in that poem, if you will, is namespaces are a honking good idea. We should use more of them. And so what namespaces, again, are referring to is the idea that you can separate out groups of functions or functionalities or variables or things like that by putting them in their own namespaces. And then you can access them with something like this, where you say, in the scikit-learn namespace, I want to access the datasets component. And so that's a really brief intro to namespaces. I want you to be aware of that word so that if it comes up in your reading, you're familiar with it. But there's a lot of other implications with namespaces that we don't have time to go into here. So I'm going to execute this cell. And you notice that that took a little bit of time, although everything seems to take a little bit of time in Colab. But that took a few seconds, let's say, because what it had to do is actually load all of the source code that's part of pandas. And then the part of scikit-learn that is that load Boston function, it had to load that into our Python environment. And so sometimes big packages can take a long time to import and load. So that's how we do that. And generally, import statements appear at the very top of a notebook, not mixed in here. But since I'm walking you through a tutorial linearly, it's okay to do this here. But generally, again, from a style perspective, you want to get all these imports at the very top of your notebook so that when somebody hits that notebook, when they open that notebook for the first time, they can see all of the things that they have to have available, all of the packages that they have to have access to in order for that notebook to run. So that's the motivation behind putting your import statements at the very top. Okay, so I executed that. It didn't print or return anything, which is pretty typical of import statements. All right, and then we imported this load Boston function into our namespace. So now we can call it like we would call any other function. And that's what we're going to do here. So the first thing that we do is we call this function and put the output of this load Boston data set into a variable called dataset. We could argue whether that's a good name or not. And then it turns out there on this this dataset object, there is a string that probably is written as a bunch of triple double strings for those of you who are wondering how it's done. There's a multi-line string called DSCR, which is supposed to be description, that describes this Boston house price data set. And that's what we're going to use for today and tomorrow. And you might think, well, hey, why aren't we using a chemical engineering data set? And we could, but the Boston housing price data set is ubiquitous. It's used all over the internet. And so if you start looking around, well, how do I do this machine learning algorithm, right? It's pretty likely that you'll find an example of it using the Boston housing price data set. So it's a good data set for us to use because it's used everywhere. And from reading this, again, it's a data set about housing prices in Boston. And the publication was in '78, but I think the data were collected in, say, the mid '70s or something. And the data set has 13 numerical and categorical values. And here they are. Here's what the 13 are. And they are crime per capita, so crime rate per person, the proportion of residential land zoned, the proportion of industrial or non-retail, non-residential land zone, the concentration of nitric oxide. So what this was doing is looking at sort of how housing prices are affected by things like crime, pollution. Nitric oxide is a pollutant. The size of the house, how old the houses are, how far the particular house is from centers of employment in the city of Boston, and a number of other things that you can kind of dig into here and look at. So this is the housing price data that we're going to play with, and that's kind of the general description of it. So as I mentioned, the sort of basic component, the sheet of a spreadsheet, if you will, of Pandas is a thing called a data frame. And so if you remember up here, we imported Pandas. And so now we have this thing called Pandas in our namespace. And we can reach into there and call the data frame function, which creates a new empty data frame. And then we put that in the in the variable df. So let's do that. And then let's actually look using this sort of the df, as the last entity in a cell, and it's an empty data frame, right? So what we did here is we created an empty data frame with no rows and no columns. It's not particularly useful to us. Now, there's one other thing I want to do before we really dive into the Boston housing price data, and that's talk about imports using a named or an alias import. I'm not a big fan of alias imports because it obscures the name of the package that somebody wanted to, like, purposely chose. But because we're going to use the word pandas so much, it has become commonplace to replace this with import pandas as PD. And so what that does is that allows us to use PD down here instead of pandas, right? And so it just shortens our lines of code. The other reason to do this is that everybody else in the world does this when it comes to pandas. And so if you just get in the habit of importing pandas as PD, it'll make it much easier to use resources like Stack Overflow when you're trying to dig into what's wrong with my pandas data frame. So I would say import pandas as PD, even though it's kind of obscures your intent. But everybody else in the world is doing it, so why shouldn't we? All right, now let's actually convert the pandas data into convert the Boston housing price data into a pandas data frame. And we can do that right here. And so again, we're setting the value of the variable df to be a pandas data frame. And we're reaching into the data set. So remember, data set is up here where we use load Boston to populate the variable data set. And I've done a little bit of lifting for you and gone and looked up that the actual data of the data set is in this data attribute. And the names of the columns here are in this feature names list. And so if we use this shorthand here, we can create a data frame. All right, so that's great, right? Now we have a data frame, and you might be asking, well, what do I do with a data frame? Well, let's start by looking at the data frame itself. And one of the best ways to do this is to look at the first couple rows of the data frame. And we have these two functions that apply to a data frame. And remember, the way append applied to a list, we have the object here, our data frame, and then the dot, and then the function that we're calling, the method that we're calling. And in this case, we're calling head, the head function, head method on our data frame. So let's do that here. And what head does is it prints the first 5 records, 5 rows of our pandas data frame. And you can see here. And this column here is interesting because this is the index column. And again, I want to emphasize that anytime you have the concept of an index in Python, the default is going to be to start at 0. And so the first 5 rows, we have row 0, row 1, row 2, row 3, row 4. Okay. And then remember, this is our per capita crime. So this is apparently a lower crime area and a higher crime one. And then the zoning, let's see, ZN was, I think, the residential zoning and so on and so forth, right? So there's our data frame. And we can do the same for the end, right? We can look at the last 5 records of our data frame. And here we see the last 5 records. Now, we started counting at 0. And we ended counting at 505, which means we have 506 records. Let's come back up here to our example, and it says number of instances, 506. So this makes sense, right? We successfully generated a data frame from these data, and all is good with our data frame. Sometimes, however, you don't want to do what we just did, which is go in here and count up columns and then head and tail and count the number of rows. You just want the shape. And that is what the shape attribute is for. So up here, we were calling the function or method tail on our data frame. And here, we're doing something that looks kind of similar, right? We're asking for this thing shape on our data frame, but we haven't put the parentheses in. And that's because this is an attribute, not a function, meaning we don't actually have to call any code. We don't have to execute any code. This is a value that's been set and is persistent on that data frame. And so we can just retrieve that value rather than calling a function to compute that value. So there was a question, which is, how did each column get a title without an index? Without an index. And so that's a great question. When you create a data frame or you load data into a data frame, unless you give some hints to pandas, by default, it will create an index column whose numbers run from 0 to 1 minus the number of rows. So that's where the index column came from. These column titles here were added when we initialized the data frame because we use this columns attribute, sorry, this columns parameter or argument in our call to the data frame initialization function. And let me just, whoops, that's not what I want to do. Let me just show you quickly. Can't tab complete that. Oh, that's why tab completion didn't work, right? Okay. So data set features, this entity that we got for free when we loaded the Boston housing data. You can look at this and see this part right here. Let's, for the sake of simplicity, ignore those other pieces. And if you look at that, you see brackets and things separated by commas. And so that should give you the intuition that effectively the dataset.featureNames attribute is a list. It's technically a NumPy array, but it functions very much like a list and can easily be converted and coerced into a list. In fact, we can typecast it into a list like this, right? And now we have a straight old list. And so when you initialize the data frame, if you supply a list to the columns, that's how it arrives at the names of the columns in your data frame. So that was a great question. Okay. Great. So we talked about the shape attribute, and again, it's not a function or a method; it's an attribute, meaning it's basically a variable that always exists, right? And we can see that, and this jives with our understanding where we have 506 rows and 13 columns. All right. Let's actually look at the columns again. And here we go. This is our columns, right? And again, this is the names of our columns. And intuitively, we can kind of imagine that this is a list again, right? It's a special data type, but it's super easily converted into a list. So the df.column or the .columns attribute is the list of column names. And then the df.index is our list of indexes. In other words, the row identities 0 through 505. And if you recall from yesterday, we talked about the range function. And so this range index is a very similar concept where it starts at 0 and stops at 1 less than the upper bound and goes 1 by 1 by 1. So we go 0, blah, 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 and stop at 505 because 505 is 1 less than 506. So that's how our indexes are derived. And then the other one that we want to talk about quickly is our data types. And remember, we talked about the primitive data types being things like strings and integers or numbers, and then floating point numbers. And if you put your Wayback hats on to yesterday, Stephanie asked a great question about the different types of floating point numbers. And I responded saying that sometimes you need bigger floating point numbers to store a value, and sometimes you can use smaller floating point numbers. And what we're seeing here is that all the values that we pulled in, meaning all of these values in this table are floating point numbers. And that, again, that aligns with our understanding of how floating point numbers work, because there's a decimal point in all these numbers. And the 64 here is a sign of how big that floating point number. And what that means is there are 64 bits that are used to represent that floating point number. And at this point, I would refer you to the IEEE standard for floating point numbers. I thought somewhere in here there was a nice, oh, here we go. And so, you know, this is 32 bits here. And let's see if there's a 64-bit layout. Yeah, there's 64 bits. So anyway, in your copious spare time, you can go look up the difference between a 32 and a 64-bit float. But the important point is not the number afterward. It's this thing here that tells you it's a floating point number. Okay, so all of our data here are floating point numbers. They're not integers, they're not strings, they're all floating point numbers. And the fun fact is that Pandas is actually pretty good about trying to determine what the data types are for you. And so generally speaking, I look at the data types, but don't need to change them all that often. When it creates a data frame, it's pretty good about guessing the data types. All right, now think about how we access elements in our dictionary, right? We used a name and accessed the element in the dictionary, and then what we got was the definition of that dictionary, right? We got the value associated with that key. Well, there's a similar concept with our data frame where we can ask for the column associated with the column name crim, right? So here's our data frame, and then we're referencing it with this bracketed references, the way we would do for a dictionary or even a list. And then unlike a list, though, we put in the column name here. So if I do this, I get out the values of the column, right? And so just to prove this to ourselves, let's look at the value for 0, and then we'll go look at the value for 505. So 0 is 0.00632, and if we scroll up here, we see 0.00632, and then down here for 505, it's 004741, and in fact, that's what we see for the last number. So there we go. We can access our columns by using this notation, and we can do neat stuff with our columns with that notation. And so remember, this is per capita crime. And if we wanted to change that into a per 100-person crime, we could take our column here and multiply it by the number 100. And I put the period in here to make sure that it was clear. My intention was to use a floating point number. That's superfluous. I didn't need that. But again, I like to do things like, I like to do things like that to signal to the reader what my intention was with the data type there. And so basically, we created we've calculated a complex quantity. We've calculated a complex quantity here by multiplying it. What if we wanted to save this back and create a new column in our data frame that was this value, so crime per 100 people? Well, the same way we access the thing in the same way we set a thing in like a dictionary or even in a list by referencing the variable and then putting the key in here. That's how we can create new columns, like new computed columns, very quickly with a data frame. So let's do that real quick. And now we have a new column in our data frame, crime per 100, that we calculated by using the crime column and multiplying it by 100. So if we do a head really quickly, we can see we now have a new column over here at the end that has this first column multiplied by 100. Now that's a pretty trivial example, but I just wanted to show you how easy it is to create new quantities, new columns in your data frame. And we could have done things like had one column be multiplied by another and had that be a new column. It doesn't have to be a scalar or a static value. It could be other things. Okay, so there was a question that said, how did you get it to expand to show values 5 to 100? You have to specifically call them up, or is there a way to get to everything? I see. So here, when I printed had to print the column out, this is the default behavior, and there is a way to get around this, and Wes has put that in the chat, and I'm not going to play with that right now because you can do it with your spare time, but you can change how many rows you want it to display, but by default it shows the first 5 and the last 5. And similarly up here with head, let me just do it down here. With head is that I can change the number of rows that it displays by putting an argument in there and seeing it. And if you want to see the usage for that, we can get Google to show, or Colab and Jupyter Notebooks to show us. And so it's expecting a single argument called n that defaults to a value of 5, and that's the number of rows that it's going to return. Okay. The next thing I want to talk about is kind of breaking up data into discrete intervals. What you probably want to do very frequently is get a look at the data and try to break them up into groups. And so one way to do that is to cut up your data, divide up your data into sections. And so let's do that. Let's break up, let's use Pandas and the cut function on our crime column, and let's cut that up into 10 groups and then save each row's group back into this column. So let's do this, and then it might become a little bit more clear what we're actually trying to do here. So here's our crime column here, and we've effectively broken up this crime column into 10 different groups, so that if we looked across the range of values for crime, that would be broken up into 10 evenly sized groups. And then a signature for which group a given row belongs into is placed into this crime group. So this row here, row 0, happened to be in the crime group that ranged from, I don't know why we have a negative value there, but from effectively 0 to 8.903. And I don't see anything in these first 10 that's in a different group. Let's see if there's anything in the first. No, these all seem to fall into roughly the same group. Oops, I didn't want to do 50 there, but I did. So let's just see if we can find one that's in a different group. And I don't see one quickly that's in a different group. So let's just put that back. Oops. Okay, and then if we look at the data types again, now what we see is we've got floats for all of these, and this thing here is called a category. And it's called a category meaning that it's no longer an integer or a number or anything. It's which bin in that group of 10 bins in our division of the crime column a particular row falls in. But we can start to use this to group data, which is sort of neat. So let's look at our, here's our DF crime group that we've created. And so again, this is for each row, there is a category assigned to which part, where in our histogram of values of crime this particular row falls. And then we're going to count up the number of rows for these. So let's execute this. All right, so remember, we talked about here, this was this thing that we kept seeing over and over here, right? It's all these things here, right? And that sort of makes sense that we couldn't find any, right? Because of the 506 rows, 439 fall into this first bin. right? So if we were to draw out a histogram of this, right, what we would see is a rapidly declining function or a rapidly declining display. And that's because the vast majority of areas are relatively low crime. And then there's a small number of higher crime areas that we see. Okay, and if we try this on a continuous, so this categorical variable is what we call a discrete variable, meaning it takes only discrete values. It can only be this range or this range, right? It can't be a continuous number that has an arbitrarily long representation of decimal places or significant digits. And so if we try to do this on a continuous variable, we get really weird results, right? Because it's how often does this exact floating point number appear in the database or in our data set. And you'll see that the vast number of these are 1, right? Because the floating point numbers themselves are relatively unique and they don't appear over and over and over again. Not only that, remember, it's always thoughtful when you try to compare 2 floating point numbers for identity. And so what you can see is that we don't actually break up the data very well because there's only 2 numbers that appear more than once, and then all the rest are singletons. So this value counts here is really about telling us how many times we see a particular value appear in a column of our data set. Okay. And then if you remember, I talked about the nitric oxide, nitrous, oh boy. Come back up here to the data, the nitric oxide concentration. It would be fun to live in an area where there was a high nitrous oxide concentration in the atmosphere, which is what I wrote in our notebook. Let's come back down here to here. Yeah, so NOx is nitric oxide, not nitrous oxide. We're not around a whole bunch of dentist offices. If I do this to our nitric oxide concentration data, what we can see is that there's fewer decimal places, and so we get a little bit better binning, but it's still a difficult thing to do on a continuous variable. But it is kind of interesting because we see that there are some numbers, there are some higher values for the NOx concentration that do appear more than once. So this can give us a little bit of an idea about some of the nature of our data and some of our data exploration. All right, so we're getting very near the end. All right, and I want to talk about this idea of group by. And the idea of group by is you have something like a categorical variable, so a range of values that something exists in, or we all put our favorite colors, so we're all rows. Each one of us is a row, and then the first column is our first name, second column is last name, and the third column is our favorite color. And then what we want to do is group the number of people that have the favorite color of red and then count them up. So that's a typical group by operation. So you have some data here, X and Y, and we split those data up into values for X. So here we have all the A's and all the B's and all the C's. And then we do maybe apply, and sometimes apply is count. So that's what value counts is doing. Sometimes it's mean. So here it's taking the mean of these 2 values. So 2 and 4 is 3. So the function that we're applying to each split is to take the mean. And then we combine it back together and get what's effectively a new data frame, right? And so here is our ABC, and then we take the mean of all of the values of A, and the mean of all the values of B, and the mean of all the values of C, and we create a new table. And so this is effectively the concept of a group by with a function applied. And this is an incredibly valuable concept. This persists all over Pandas, but also in databases and database languages like SQL. This is a really important concept to have in your mind. And so remember when we did this, we had our crime group column, and this was our grouping of the crime rates of rows into different crime per capita. And then here we were counting the number of values in each group, right? And so we saw 439 of our 506 samples exist in this low crime group. Great. We can do this again in another way, and actually get a table out of it. And that's to take this group by function and group our entities by their crime group, and then count the number of appearances we see. This is not super informative because up here in this bin, there were 439 things. And so when we look at this, we see 439 all the way across because there were 439 examples of housing age within this group, right? So count just counts them up. It doesn't do anything particularly informative about it. What might be more interesting to do, like we had up here, is to compute the mean. So to split them up into their crime group, and then for each crime group, compute the mean of the age or the NOx concentration or things like this. And so that's what we're doing here, right? Is we're grouping the rows by their crime group, which we created by cutting up our crime column into 10 groups. And when we're asking for the mean. All right. And when we say mean, we're asking for the mean of each column. So I just want to emphasize that, right? And so if we look here, here's our crime group that has 439 examples. And then the average industrial zoning, for example, in there is 10 point something. And that's interesting because it's striking to me that the industrial zoning here, at least trivially, I'm not an expert in these data, but it's lower when in the lower crime group, which is sort of interesting. The housing age appears to be lower, although it's pretty confident to say that these areas are undersampled, right? If we have 439 examples here, we have 44, 14, 1, 3. So we're starting to get into lower numbers of examples. Okay. If you want to do something like this, however, you might want to actually reference a particular column. And so here's our group by, right? And then before we did .count or .mean, and so that was taking our group bys and applying a function to it. Here what we want to do is we want to pull out the NOx column. So basically we want to pull out this column from this summary and then describe it. And I'll just use the describe function to show you because it's more intuitive. So count is what describe does. It returns a new data frame with some descriptive statistics of the data. And so we had 439 examples in this crime group. So we see 439 here. Makes sense, right? What we see is the mean of the crime group here is 0.5. The standard deviation of the crime column in this group is 0.11. And the min is so forth. And then we have the quartile variables and the max. So describe can be a really great way, along with group by, to get a lot of information really quickly about your data. And so what I want you to kind of grok in your head, right? Sorry, for those of you who aren't Stranger in Strangeland fans, what I want you to understand in your head is that we have this general form of manipulating our data, of grouping them in a pandas data frame that looks like this. We have our data frame, our data object. We're calling the group by function on that data frame. We're telling it what to group by. And so again, this works better with categorical variables than with continuous variables. And then we're performing some aggregate function on them, right? So we did count, we did mean, and then we did describe. We could have done min, max, standard deviation. So we had a number of other aggregate functions that we could do. And so I am not gonna go through this final example because it's pretty much a lot of what's in the breakout. So I think this is a good point for us to actually end the tutorial, if that works for you, Stephanie, and take a 10-minute break.
That sounds great. And if anyone has questions on Dave's tutorial, there are office hours tomorrow. You can come and ask questions. But let's also all thank Dave for an amazing CHack tutorial 3. Woo!
Thanks, Dave.
Thank you for all the awesome questions, folks.